The sun is 400 times wider than the moon. So how can this tiny moon cover it almost perfectly? Even stranger, the moon goes around the Earth every month. So why doesn't an eclipse happen every month? And why did the corona I saw with my own eyes look white, while the photographs make it look gold? These three questions lead to one remarkable answer.
It's spectacular, as expected. And the crowd's going crazy. Here we are. Look at that, folks. That is so beautiful. Oh my goodness.
Is there some physical reason for all these numbers to work out? Or are we witnessing an extraordinary cosmic coincidence? Here's the first puzzle. The moon goes around the Earth about once a month. So if the moon regularly passes between the Earth and Sun, why don't we get a solar eclipse every month? Because these orbits aren't all in the same plane. Earth orbits the Sun in one plane, called the ecliptic, but the moon's orbit around the Earth is tilted about 5 degrees relative to it. Most months, therefore, the new moon passes either above or below the Sun from our point of view. But the two orbital planes intersect along a line. The two places where the moon crosses the Earth's orbital plane are called nodes. And roughly twice a year, the geometry becomes particularly interesting. The Sun appears close to this line of nodes just as the moon crosses it. That's an eclipse season. If the moon is new, the moon can pass directly in front of the Sun. And that's exactly what happened here. Okay, eclipse time is still about 45 minutes away. And that's just when the process starts, and it'll take another 45 minutes to an hour before we hit totality. But I've got a little cool place to sit. I've got my tripod ready, multiple tripods, and then inside I have some camera gear that I'll be mounting, and that only takes a few minutes. So I'm all set. Oh yeah, and I've got my space shirt on. I did this the last time we saw an eclipse too. And I thought I'd be all alone. You can definitely feel the change in temperature. We're probably about almost a quarter of occultation here. So totality is just around the corner. We're about 4 minutes away from occultation. I wanted to show you the sky, what it's looking like. It's kind of getting a little eerie. The temperature has definitely dropped. In this time lapse I recorded during the 2026 total eclipse in Spain, you can actually watch that orbital geometry playing out. The dark silhouette of the moon gradually moves across the face of the Sun. We're literally watching the moon's orbital motion projected onto the sky. And when the alignment becomes precise enough, the moon's darkest shadow finally reaches Earth. But that introduces an even bigger mystery. How can the tiny moon cover the enormous Sun? The diameter of the Sun is approximately 400 times greater than the diameter of the moon. So how can the moon possibly cover it? Well, that's because the Sun is also roughly 400 times farther from the Earth than the moon is. That means that from where we're standing, the Sun and moon appear almost exactly the same size in the sky. And that's the great cosmic coincidence. One of the things about these eclipses is it's really driven by gravity and the velocity of the planets in their orbit. So that inertia, coupled with the gravity and the masses that just happen to be right, keep the planets in these orbits that give us these eclipses. But gravity didn't deliberately arrange this 400 to 1 match. It just happens that right now in Earth's history, the moon is approximately the right distance to cover the Sun while leaving its outer atmosphere exposed. And I say right now because the moon is moving very slowly away from Earth. So this remarkable coincidence won't last forever. I recorded the eclipse with a 360-degree camera, and look what happened. Around the Sun, the sky has become remarkably dark. But now look toward the distant horizon. Wait, if I'm standing in the moon's shadow, why is there daylight over there? Well, it turns out that we're looking toward places closer to or beyond the edge of that shadow, where the sunlight is still reaching the atmosphere. It's almost like standing underneath an enormous dark umbrella and looking toward the daylight beyond the edges. And then I noticed something else. When I saw totality with my own eyes, the moon looked intensely black and the corona surrounding it looked almost silvery white. But afterwards, I started looking at photographs of the same eclipse, and many of them looked like this: a yellow, gold, and sometimes reddish corona. So I started wondering which one is real. Surprisingly, what I saw with my eyes is quite close to the corona's natural appearance. The visible corona is essentially pearly white, and much of its visible light is ordinary sunlight scattered by free electrons in the sun's extremely hot outer atmosphere. And those beautiful feathery structures, those are real. The corona is shaped by the sun's magnetic field, producing enormous streamers extending outward from the sun. So why do photographs look so different? Because your eye and a camera experience totality very differently. Your eyes have just gone from brilliant daylight to an extraordinarily dark scene. Your visual system is adapting rapidly, and the contrast between pitch black moon and the brilliant bright corona is enormous. A camera can do something different. It can collect more light, it can combine multiple exposures, and it can change the white balance. And afterward, we can increase contrast, saturation, and color. So a photograph can reveal structures and sometimes colors that were extremely difficult to perceive with your eyes. The photograph isn't necessarily showing the eclipse more accurately, it shows it differently. And that's what makes a total solar eclipse so extraordinary. Two tilted orbital planes lining up at the right time. A moon 400 times smaller than the sun happens to be roughly 400 times closer to us. And you have to be standing inside a relatively tiny shadow racing across the surface of the Earth. So for those few minutes, you're not simply watching the moon pass in front of the sun, you're actually standing inside the moon's shadow. And if you look around, you can even see the daylight waiting just beyond.